Hi everyone and welcome to the next lesson for grade 8 topic 3. If you haven't figured it out already, I record a lot of these videos back to back even though you are probably watching them on different days. And just like the rest of the videos in topic 3, I still have my parents' dogs and my dogs with me, so I apologize in advance if you hear them barking in the background. So today we are talking about negative exponents and zero exponents and what they mean and how we interpret them. So let's go ahead and dive into this first example that I'm creating for you that I would also like you to write in your math journal. So go ahead and take a moment to copy this chart out and we're going to write in some examples. So we're going to start here with 3 to the 5th. And 3 to the 4th, and 3 to the 3rd, and 3 to the 2nd, 3 to the 1st, 3 to the 0, and 3 to the -1. Oops, -1. No, 1. There we go. -1. Okay. So on this chart, I want you to go ahead and fill in what 3 to the 5th is and write it in this row right here. So 3 to the 5th. I'm going to start with 3 to the 3rd because I know that's 27. And then I think the next one is 81. So then 3 to the 5th is 243. And then I'm going to write 3 to the 2nd, that's just 9. 3 to the 1st, well, that's just 3. And then I want us to stop here and take a look at what's happening with our numbers. So what is happening between 243 to get to 81? Or what's happening between 81 and 27? What's happening between 27 and 9? What's happening between 9 and 3? Another way I can ask this is, how do I change a 9 to a 3? Maybe you said I could divide by 3. To change the 9 to the 3, I could divide by 3. And I could say that with the 27. I can change the 27 to a 9 by, again, dividing by 3. Dividing by 3. In fact, I can change all of these numbers to the number in the next box to the left by just dividing by 3. And then vice versa, I can change all of these numbers to the next number by multiplying by 3. Okay, multiplying by 3. And that makes sense because I'm going up 1 power of 3 every time I go up one space in my chart. So this is only 3 times 3, but this is 3 times 3 times 3. So I multiplied by an extra 3. So I can multiply by 3 to move this way, or I can divide by 3 moving this way. So if I keep this dividing by 3 rule, what would this box be, my 3 to the 0? If I did 3 divided by 3, what would I get for my 3 to the 0 box? Well, I would get 3 divided by 3, which would be 1. And then let's do it again. What happens if I did 1 divided by 3 for my -1 box? Well, 1 divided by 3 is 1/3. So I get 1/3 for this answer. If I were to keep going and do 3 to the -2nd, I could do 1/3 divided by 3. That one we kind of need to write out a little bit. 1/3 divided by 3. We need to keep the same fraction at the beginning, keep this, change division to multiplication, and flip this last one. I would get 1/9. Okay, and I could keep going, divide by 3, divide by 3. And I could keep going and start getting into these negative exponent areas as well as this zero exponent. So we have this special situation right here where anytime the rule is, and this is kind of a spoiler alert, but anytime you have a number raised to a 0 power, the value is always, always, always going to be 1. A lot of times people think 0 because 3 times 0 is 0. But remember, this is not multiplication. This is 3 to the power of 0. And 3 to the power of 0 is 1. Another way we can think about this that we're about to look at is, remember our division rules. We have 3 to the third divided by 3 to the third. Well, when I do this, I know that 3 to the third is the same thing as 3 to the third. So I could cross all these out. I can go 3 times 3 times 3 over 3 times 3 times 3. And I would be able to say that turns into a 1, that turns into a 1, that turns into a 1. So I have 1 over 1, which is 1. And I can say, well, my division rules state that I need to go through, if I have the bases the same and I'm dividing, I can subtract the exponents. Well, 3 take away 3 is 0. So I can say this is the same as 3 to the 0. And I can say that because of all of this math, 3 to the 0 is the same thing as 3 to the 1, or not 3 to the 1, is the same thing as 1. All right, so I wanted to show you this graph or this chart before we get into the Pearson video here. And they're going to show you an example with 4 to the third. So let's go ahead and watch this.
Since the numerator and denominator are the same, you can evaluate the expression. 4 cubed equals 4 times 4 times 4. Or 64. 64 divided by 64 equals 1. Now, simplify the expression using the property for dividing powers with the same base. Remember, that means keeping the base the same and subtracting the exponents. 3 minus 3 equals 0, so the simplified power is 4 to the power of 0. You now have two different equivalent expressions that both equal 4 cubed divided by 4 cubed. This example illustrates the zero exponent property. In the arithmetic example, negative 3 to the power of 0 equals 1. For every non-zero number a to the power of 0 equals 1.
Any number that is raised to the 0 power, whether it's negative, whether it's positive, whether it is a fraction, whether it is a decimal, any number raised to the power of 0 is always, always, always going to be 1. All right, so that's what we're working on today. So let's take a look. 18x to the 20th over 18x to the 20th. Well, if we subtract these variables, we would get x to the 0. And if we do 18 divided by 18, we would just get 1. So that's going to be 1. Let's take a look at B. I'm going to put this one in our notes. Okay, for B, we have w to the 8th times z to the 15th. We're going to look to see what they have in common that might be able to cross out. So we've got w's here, and w to the 8th over w to the 8th is 1. So I'm going to go ahead and eliminate that. And z to the 15th over z to the 8th, well, I can use my rules and say z to the 15th minus 8 is going to be z to the 7th. So my final answer here is z to the 7th. I don't even have a w in it because my w's went away to be a 1. 8 take away 8 was 0, and anything raised to the 0 power is 1. So I just have z to the 7th. Let's take a look at this one. Oops, sorry, not that. This one. My dogs keep thinking that they hear somebody at the front door, and I think it's just construction outside, which is why I apologize again for all this extra noise that you're hearing today. Okay, so let's take a look at this one. Let's deal with each item individually. So we have plain numbers. So 9 divided by 3. Let's do that first. What's 9 divided by 3, everybody? Hopefully you said 3. Let's do x to the 5th divided by x to the 2nd. Here's my next set of numbers right here. X to the 5th divided by x to the 2nd. Well, that's 5 take away 2. That's just x to the 3rd. Hopefully the color coding helps you guys a little bit here. And we'll do the y's next. Y to the 12th divided by y to the 12th. Well, that's just y to the 0, which is 1. So I actually don't even have to write the y. I just have this as my final answer, 3 times x to the 3rd. Let's do D together. X to the 0 is 1. It is not 0. Don't get tricked by that. It's not 0. And 5 times 1 is 5. So the answer to D is just 5. Now I have, here's a negative and a decimal for you to work with, which don't let that scare you. Anything raised to a 0 is what, everybody? Hopefully you said 1. It is 1. So this answer is simply 1. All right, now we're getting into our last section of the day where we're looking at simplifying this expression, which is 8 to the 3rd over 8 to the 5th, or divided by 8 to the 5th. So I want to first start this, oops, writing in white ink is not going to work. I want to first start this with the way that we learned this originally. So we learned this as, let's write it all out. 8 times 8 times 8 is 8 to the 3rd. And then let's write that for 8 to the 5th. We have 8 times 8 times, 8 times 8 times 8. All right, so we have these 8s, and we can still do the same thing we've been doing. We can cancel out the ones that they have in common. Remember, these are, even though I say canceling them out, they're really changing to 1s. So this really just changes to 1, because 8 divided by 8 is 1. So I have 1 times 1 times 1, which is going to give me 1, over 1 times 1 times 1 times 8, which is going to give me 64. So I have 1 over 64. And this works because, let's go ahead and do the subtraction portion of this now. So I can do 8 to the 3rd minus 8 to the 5th, or just 8 to the 3 minus 5. So 8 to the 3 minus 5. Remember, when you're working with subtracting these division problems, you have to work from the numerator to the denominator. So I'm working with 8 to the 3 minus 5, which gives me, oops, not crop, 8 to the negative 2. 8 to the negative 2. All right, so this is saying that 8 to the negative 2 is the same thing as 1 over 64. And let me tell you my trick for negative exponents. I have named negative exponents negative Nancy's, and negative Nancy's aren't happy where they want to be. So currently, if I were to write 8 to the negative 2, just like this, it is currently in the numerator. I could write it like this as a fraction. It's currently in the numerator, and negative Nancy's are not happy. They always want to be in the denominator. When you move them to the denominator, they are happy. And so it becomes a positive 2. So 1 over 8 to the 2nd is 1 over 64, which is how we got 1 over 64 here as well. So when you see a negative exponent in the numerator, move it to the denominator so it becomes a positive exponent, and then you get 1 over 64. If you forget that, do this math and cross out the ones they have in common to figure out that it's 1 over 64. Let's go ahead and finish this video in the next few minutes in part 2's video.